So if you want to use your financial calculator to calculate the present value, I have the inputs here. If you input future value as $100, 5% interest rate for 2 years, you compute PV, and it turns out to be $90.70. Again, you will see a negative sign on your screen, but at this point you can just ignore the sign and keep the amount of $90.70. This is how you use your financial calculator to compute for the present value based on the future value. And again, I have videos on D2L that explains how to use your financial calculator to do your time value of money calculations. So if you need to have a tutorial that show you how to use a financial calculator, check those videos out. Now, this is an example from your book about the present value application. So if we are looking at a typical furniture purchase, a lot of stores have the policy that the customers can buy now, get the furniture, but they don't have to pay for 2 years. So they will make their payment in 2 years, but within the 2 years they don't have to pay. From a time value of money perspective, selling a furniture at full price with payment in 2 years is equivalent to selling the furniture at a discount price, or say a sale. So if the interest rates are 7.5% per year, what is the equivalent sale price of a $1,000 sleeper sofa when the customer takes the full 2 years to pay for it? So if the customers take the full 2 years to pay for $1,000, then the store will receive this $1,000 in 2 years, and apparently that is a future value. So we want to find out the present value of this $1,000 to be received in 2 years based on 7.5% interest rate. And when we calculate the present value, it turns out to be $865.33. So that is like taking or giving customers a 13.5% discount. Why would they do that? Because stores believe that a lot of customers actually will not be able to pay the full amount by the end, so they can charge a high interest rate and late fees by them. But customers who do pay on time are getting a good deal. So if you know you can come up with $1,000 in 2 years, then it's actually a pretty good deal, because it's like you're getting a 13.5% discount if you get this furniture now and pay $1,000 in 2 years. So how do you make sure you come up with $1,000 in 2 years? For you, you can actually invest, or say put aside $865.33 today or now. If you can make a return of 7.5% interest rate, or say rate of return, then in 2 years this 865.33 will become 1,000 based on the 7.5 rate of percent interest rate or rate of return. So it is like you are paying $865 today. If we are looking at discounting with different interest rate over time, remember a couple of slides ago we talked about calculating future value based on different interest rate. Same kind of idea. When we try to calculate present value based on different interest rate, we have the future value now discounted by different interest rate year by year. So 7% first year, 8% second year, 8.5% third year. We just discount one by one. And after discounting for 3 years, the present value is $1,993.90. There is no shortcut function in your financial calculator to help you get the results fast. You actually have to go through the this calculation step by step, one by one, year by year to get this result. Now let's think about what we just look at as that formula. Remember, future value equals to present value multiplied by 1 plus I at the power of n. So we so far have solved for future values and present values. We can also use the same formula to solve for the interest rate or the number of years. So let's take a look at solving for interest rates. If you look at your financial calculator, you will see there are 5 variables used to solve for this type of time value of money calculations. Typically you see n, which is number of years or number of periods. I is the interest rate, present value, payment, and FV. For questions from chapter 4, payment is generally left at 0 because we do not have any regular payment. We only have present value or future value. So we can actually solve for any of these 5 variables if we know the other 4 variables. And again, in chapter 4, payment is 0. If we only know 3 variables, then there are indefinite number of solutions. But if we do know 4, then we can solve the only missing one. So here is a typical example for solving for interest rates. So if we bought a gold coin for $3.50 3 years ago, and now we can sell it for $4.75. So this is an investment that required an initial investment of $3.50 at the beginning, and then 3 years later it will become $4.75, and that's what you see on this timeline. So what kind of annual return would you earn every year in these 3 years so that your $3.50 will grow into $4.75? If we enter the numbers into your calculator, so we know n, 3 years, we know the present value, $3.50, we know the future value, $4.75. We're actually trying to compute for the I, and the result is 10.716, and that tells you that we are earning an interest or return of 10.72% every year in these 3 years. You notice in your calculator we are putting a present value as a negative number while the future value is a positive number. You can also put the present value as a positive number, then the future value as a negative number. If you don't do that, you will see an error message in your calculator. So in this case, between the present value and future value, one number has to be positive and the other number has to be negative. It doesn't matter which one is positive, which one is negative. Just remember one of them is positive and then the other is negative. The time value of money concept and calculation can also be applied to growth problems if you want to solve for growth rate. So if we just use the same set of numbers but put it in a different context. For example, your company currently sells 350 million of merchandise per year, so that's your revenue, and has grown 7% per year in the past. So how long would it take before the company reaches 500 million in revenue or sales? And how long would it take for the company to reach 600 million? So 350 is what you have now, so that is a present value. If you want to achieve 500 in the future, that is your future value. And if the growth rate is 7%, we can take that as the rate of return, or say the interest rate. So that's our I. And if we want to know how many years would it take, we solve for the n number of years. So 350 growing into 500 based on 7% interest rates, and then now we are computing for n. N turns out to be 5.27. So a little bit more than 5 years. And again, you notice that between present value and future value, one number is positive, the other number is negative. If you want to watch the video about how to solve this question, I do provide the links here, and just go to that website and watch the video. If you want to know how to solve the question using your calculator, there is a video for that as well. So in this chapter, we basically look at one formula. Future value equals to present value multiplied by 1 plus I at the power of n. And once you write down that formula, you understand we can solve for one of the variables or factors in that formula if we know the other three. Or we can say we can solve the missing variable if we know the other four, if we take the payment as 0, always 0 in chapter 4. So we discussed how the power of compounding interest increase our wealth, and what factors affect the future value or present value of a single cash flow. So by now you should be able to identify, for example, when interest rate goes up, how would the future value be affected? And then if interest rate goes up, or say if you use a higher interest rate, how would your present value be affected? So those kind of conceptual questions. And chapter 4 is actually the very basic of time value of money concepts. And once you understand chapter 4, which is about one single cash flow, then we can move on to chapter 5 and talk about multiple cash flows, the present value, future value of multiple cash flows. So that's chapter 5.